Up next is Steve Boyer with IBM.
Okay, my name's Steve Boyer. I work at IBM, and we do a lot of things here, more or less everything you heard in the last two talks. And we also do some new things. And what I'd like to do today is walk you through some of our current activities, because I think it might be worthwhile for the community here. And I should also mention that a lot of the things that we do that employ the ChemAxon tools are actually used underneath the covers and in the background. So we couldn't do any of the work that I'm about to tell you about without having some of the wonderful libraries and tools from ChemAxon. So let's start. A long time ago, we started curating various documents, patent and other documents, for chemical entities. And the idea here is that you have text, you have words in the text, and we were identifying the chemical names within the text, and basically taking those chemical names and converting them into smile strings. And then those smile strings were going into a database, and that database was being used to do substructure searching so that you could identify where those chemicals occurred within the context of the text. So for this, we use the ChemAxon name destruct. We use the ChemAxon JChem down here, and life was very well and good, and we could extract chemical names, convert them, and basically search on them. What we're doing more recently is we're now taking those smile strings. Oops, let me go back. Sorry about that. We're now taking those smile strings and we're converting them into InChi's, and then from InChi's to InChiKeys. Here's an example of an InChiKey for the word aspirin. So now, in addition to having the smile string for aspirin, we also have the InChiKey for aspirin. And then we take that and we reinsert that into the text of the document to build what we call augmented text. That augmented text now has the word aspirin as well as a little tag that says, I'm an InChiKey, and by the way, I'm specifically this InChiKey. And then we re-index this with SOLR so that the InChiKey is actually indexed as if it were a word within the document. To do this, we use several as I said, ChemAxon tools under the covers, and it basically enables us to do this. So in addition to doing this with the chemicals and the chemical names, we're now doing it with gene IDs and gene aliases. So for instance, if the term JAK3 occurs in the text of the document, we'll identify that word JAK3 and we'll say, this is a gene ID. And by the way, it's the NCBI gene ID 3718. So then what we do is we take that and we go back into the text, we augment the text, and we say this term JAK3 is in fact this gene ID, and it's the specific one. And again, that all gets indexed as if it were a word. And we do the same thing with all the mesh terms. So mesh terms are medical subject heading terms. They're rather complex. We have terms like signs and symptoms. These would be words like headache, diarrhea, vomiting, nausea. We identify every single one of those 680 mesh terms for signs and symptoms, and when we identify that in the document, what we do is we say, this is a mesh term. We identify the mesh term, and we say, here's the word headache. It's a mesh term, and by the way, it's a C23 mesh term. And so then that gets put back into the document. So here's an example of how some of the text can be augmented. So what we're doing is we're actually going through the entire patent corpus, and we're rebuilding the text, and we're re-augmenting all the text within the whole patent corpus and the Medline corpus, and we're identifying all these different entities, and then we're re-indexing it. And why would we want to do this? Well, it gives us a lot of capabilities to do things that you could never do before. These capabilities include things, and I'll go very quickly here, such as batch searching. For example, the folks at BMS wanted, before they file a patent, they wanted to be able to say, here's 100 compounds, 300 compounds. How can we rapidly search those to find if any of them occurred in a patent before we go ahead and file an application? So what you can do is you can simply paste the whole list of InChiKeys in here. You can just click search, and you can say, I only want those that appear in claims, and now what you get back is you get a hit list that shows you if any of those molecules that you entered occurred in the claims or in another part of any patent document or Medline document. We can do the same with Medline. Here's another quick example with gene IDs. What you can do is you can simply enter a list of InChiKeys in here. I enter a list of InChiKeys, and basically I go down here and I say, I want to analyze these InChiKeys. In this case, I want to analyze patents, and I want to analyze them for genes. So you simply click patents, the patent field, say gene IDs, and what it'll do is it immediately come back with a hit list that says, oh, 1 minute, okay. Here are all the molecules that I entered. These molecules are were entered as InChiKeys, and then basically here are all the genes that occurred. These are the NCBI gene ID numbers, and these are the number of occurrences, and if you click on those numbers, it'll take you immediately to the references. You can do all kinds of other types of data mining. I don't have time to go through it all, but you can draw a molecule. Here's another quick example. You draw a molecule and say you want to analyze it for mesh, and here you can select which medical subject heading you want, in this case C23, and then it gives me all the articles, and here what you see are all the co-occurrences for that particular molecule for any mesh term, whether it be headache, nausea, or what have you. So it's a very quick way, and it opens the door to do all kinds of new and wonderful data mining, which stop by or just contact me someday and be happy to tell you more.